like to go ahead and get started. Welcome to Introduction to GIS. My name is Blake Lightham. I'm a GIS and UAV specialist at the Center for Geospatial Technologies. I've been full-time staff for almost a year and a half. Glad to see you all can make it on this cruddy Friday morning, but excited you're all here. To start with, all the data, the tutorials, the PowerPoint presentation, everything is already on the machines you're working on, so I'll show you where to access that if you'd like to follow along with the PowerPoint. These machines have two hard drives here. Everything is stored on what's mapped as the D drive. So if you can see my mouse here, the Windows Explorer in that lower left corner, we're going to open that up. I'll pull it up here. On the left-hand side, under computer, we have our C drive. We also have this D Data 2 drive. If you click on that, you will see a list slightly different from mine. But what we're looking for is a folder called Introduction to GIS. And within that folder is two subfolders, data and handouts, and then this PowerPoint that I'm going to give if you'd like to follow along. So as I go, feel free to stop me, ask questions. If you need to see something again, I'm more than happy to do it. If you need help finding something, raise your hand. I can come around. I like to keep these pretty relaxed and somewhat informal. So if you need to see anything again, just let me know. So I'm also going to pass around a sign-in sheet on this tablet. Good morning. Feel free to grab sign-in on any of these machines. What I'd like to do is just go around the room and have everybody quickly introduce themselves and your department. And quickly what you're hoping to gain from the session today. This is the first in a series of sessions. We offer all of our workshops on demand, which means that once we have enough registrants, we send out a poll and schedule these. We also, in addition to those, offer this regular series we've done. This will be the fourth semester now, starting in fall of 2016. So these are designed to give just a quick introduction to a variety of skills, concepts, and knowledge in using GIS, and we'll also do some other software. Again, to be quick introductions to every topic. We don't have the time to dive in, but it should be more than enough to get you all up and running and dangerous as GIS professionals go. So if you don't mind just quickly going around and introducing yourself, and if there's something in particular you're hoping to gain today, or if you're going to attend the series from the series as a whole.
Good morning, I'm Chloroplast Map from PNS department, and I just want to have like an overview.
I'm Mariela Fernandez. I'm an assistant professor in Parks, Recreation, and Tourism, and I'm starting a project that utilizes GIS. So I have a GIS person that I would like to understand this as well.
Great. Thomas Willow, Environmental Sciences, just trying to pick up a new skill that's not relevant to my research now, but
I'm Anthony Shinsky. I'm also in Environmental Sciences. I want more targeted pencil distribution for animals.
Okay, great.
Kenneth Whaley from the Econ Department. I want to get to spatial statistics questions you have.
Joe Keelan, professor in entomology and applied environmental sciences over at Catholic. I'm trying to learn something about how this stuff works.
You and I worked together on a project with some GIS work, mapping the distribution of that.
Right. I'm trying to figure out how to do it.
Hi, morning. Name's Carl, and I'm in PhD at Forest Resources, and our research project is in spatial evaluation of expertise. GIS is pretty much a critical aspect of the project.
My name is Henry Bush. I'm a master's student in the environmental engineering department. And I know a little bit about GIS for my research.
My name is Anne-Marie Frank. I study English and Geography for being a secondary schools teacher. And I already have some basic knowledge in Arcgis, but I think it would be fun to know some more, and therefore I attend the series.
My name is Brian Sherenta. I'm from the, I am in the Clemson Live department.
Brian Gaines, I'm a PhD student in Rhetorics, Communication, and Information Design program. And I want to learn more about GIS to help my research, which studies technology and surveillance.
Are you a colleague of Stephen Quigley?
Yeah, we're in the same cohort.
Okay. So I don't know if he sent you over.
He mentioned it actually like a year ago, so I finally got around to it. Awesome.
I'm Jennifer Thaxton. I'm with the fire department, and I am the program coordinator for the AEDs that are on campus and the trauma kits that are going to be installed. And I'd just like to be able to map those out and also make our EMS run data a little more interesting to look at.
Hi, I'm Michelle Heidinger. I'm a doctoral student in the Planning Design and Built Environment program. My research is going to be in physical activity and adolescent behavior in the built environment, neighborhood design, and neighborhood patterns, and park design and park patterns. And I actually took an Arcgis class back in 2005, and I have not been using much since. I'm sure technology has changed a lot.
It has. What we'll do today hasn't changed much, quite honestly, but the other stuff we'll get into has.
And we used it in public health, and I worked in the state health department, and I worked at CDC, so I'm familiar with it. I'm sure things have changed in some way since I've taken it in 2004 or 5.
I took my first class in GIS in 2009. Arcmap hasn't changed much, but everything else, the cloud, mobile devices, all the other technologies available has changed dramatically.
I'm Michelle Streeter. I'm a master's student in the Department of Forestry and Environmental Conservation. I see a lot of people using GIS and it making their lives easier.
That's it.
I'm Hannah Clemson. I'm also with the Forestry and Environmental Conservation Department. And while I do a lot of spatial mapping, I don't do it in ArcGIS. And better to broaden my horizons.
What do you normally use?
Program R.
I am Scott Anderson, and I'm actually with HRP Associates, a local environmental consulting firm. We do site investigation and mediation. I lead that team there. We have a partnership with the Geospatial Center here. So here today to improve our skills and understand what we can do to take us to the next level.
I'm Anthony Herman, I'm a geologist, also with HRP Associates. We regularly use GIS and I like to hone in more skills, try to make it easier.
My name is Storm Caldwell. I also work at HRP Associates. I was in the geology department when I was in school here. I'm in this class and I'm interested in learning more about the 3D aspects and life art stuff.
Great. Thank you, everyone. What I like to do, I mean, it gives me a sense for who's here. I get a different group, you know, every time we hold one of these workshops, but this really highlights one of my favorite parts of my job is how many different types of people and research and work I get exposed to. My background is in geology and hydrogeology, but now I work every day with people in economics, plant and environmental sciences, the biologists, emergency managers, parks and recreation people. I mean, just pretty much every discipline or branch of study has some use for GIS. If your data has some spatial component, if it exists somewhere in relation to the Earth, there's some need for GIS. So, all right. We'll get rolling then. Jim Lemoyne, I hope I'm introducing or saying your name properly as well. He's a technician at the Baruch Institute of Coastal Ecology and Forest Science, who's hoping to refresh his mapping skills. So he's also joining us remotely. Thanks, Jim. So what we're going to do today is I'll give a quick introduction to GIS. We'll talk about what it is. And most of the session is just going to be hands-on activities. Most of our workshops are hands-on. We don't want to stand up here and lecture you. We want to teach you how to use these software packages. So we give a variety of hands-on exercises. What we'll do first is we'll preview data in GIS using a particular software, and then we're going to take those data, make a map, use some of the attribute information of the data to symbolize it or really plot it over space, and then talk about how to export a finished map. So by the end of today, you should be able to take some data, put it into a map, put it in a report, on a website, in paper, or whatever. And then talk about where do you go from here? What are your next steps, and what resources do we offer here at Clemson University? Just by a quick show of hands, how many of you were aware of the Center for Geospatial Technologies before, let's say, 2 weeks ago? So a little over half, right? So a lot of you are new to us. We're still fairly young here at the university. We're in our, probably starting our third full year, or finishing up our third full year of operation. We're a collaboration between CCIT and the libraries. Our mission is to support all of you, faculty, students, and staff, in GIS-related activities. So whether those are teaching, whether that's research, we are here to serve you. And the way we do that is things like training events, these workshops we give. We can also offer customized class lectures. If you're an instructor, we can either help you develop sessions, or we can come and guest teach. We're supporting, I think, 6 classes this semester. Last semester we did 11 classes. We give consultations. These are one-on-one, generally hour-long sessions where you meet with one of our staff for personalized assistance. This is generally if you have a specific question for your research, how to use some part of the software, whatever that you are all eligible for after today. We manage the GIS software license for Arcgis, and we'll talk a little more about that software later. So you contact us to obtain a license. We have 2 different spaces here. We have our training room, and we also have a collaborative space next door that's open whenever the library is open. Has the same machines here. We have all the latest GIS software, 2 screens so you can feel like you're double productive. We have an augmented reality sandbox. We have a lot of cool stuff to check out. We'll take a break about halfway through. If you want, I can give a quick tour of that space. So we're here to serve you. Our website is clemsongis.org. That I've got up here. We have all sorts of resources for you on our website. Any questions about the center and what we do or offer, just quickly? All right. How many of you before today were GIS users by show of hands? A little over half. Perfect. So what if I told you that you were probably all GIS users and didn't know it? This is a trick question, right? So what does a GIS look like in everyday life? Maybe these examples are getting slightly dated. I have MapQuest directions up here, but you may have a GPS unit on your car. You have Google Maps, Apple Maps on your phone. If you've ever used Google Earth, even a Google search, where is a sushi restaurant in Clemson? You're using some sort of geographic information system through that Google interface. Right? So what is a geographic information system? What is a GIS? This is some sort of computer-based tool that's going to link descriptive information, sort of what things are, with geographic information, or where these things are located. So there are a number of different ways to describe it. Maybe an easy way to think of it is I have an Excel spreadsheet where each row is some piece of information, and each one of those rows is linked to a location. They have coordinate. That's one way, a simple way you can think of it. This is just a way to manage a database that also has a locational component, so you can map it or plot it over space. Before we had GIS, things were done entirely on paper maps. And paper maps are great. You can actually plot a lot of information on a paper map, but you're limited to what is on the page. Or if you're a geologist, sometimes there's big appendices about geologic information related to them. Still limited to what's on the page. So if you're trying to do, say, emergency routing, trying to, route your officer from an incident, or route from the station to an incident, before we had things, we just had to go and physically draw these out, and using whatever other information we had on hand, maybe we can, traffic patterns or whatever, plot out this best route. But with a digital map, we can use even live streaming traffic data about roads, blockages. We can more efficiently route and solve these routing problems, which is a very common use of GIS. But now we actually link all these data that are spatially located with a database of information. So now we're plotting, say, the distribution of different types of crime events in the city. And each one of these points tells you all sorts of other information. What type of crime was it? This was an assault with a deadly weapon. What time did it occur? Where was it? Which officer responded? How long did it take? All sorts of different information. So we're linking, again, where things occur with what they are. Does that make sense? Awesome. Here's another way we could talk about what a GIS is. It's a system for capturing, storing, checking, integrating, manipulating, analyzing, and displaying data. That's a lot of things, but the key component here is that they're spatially referenced to the Earth. And so because our data are spatially referenced, we can overlay them. The way a GIS looks at the world is it's going to model different things by breaking them into these thematic layers. So what are the streets in an area? We would have a data set or this layer that represents all of our streets. What are these districts? Voting districts, census districts, whatever. Parcels, who owns these different pieces of land? What is the land use associated with these? Is it industrial? Is it agricultural? Is it a neighborhood? We can look at things like parks. We can look at natural features, so rivers, lakes. We can even represent things below the earth, so soil, aquifers, rock types. And because they're spatially referenced, we can stack things all on top of one another and then look at them all together. So we can analyze relationships and distributions across space. So a GIS is going to break the world up into these thematic data sets we call layers. And so we can plot their data, but the GIS also has capabilities for querying our data. Right? So we have this database of information we can query against it or try to find out more information based on things that are near one another. So let's say I have a bunch of monitoring wells that I'm sampling. I'm looking for contaminant X, whatever that is. And I know that it causes cancer at certain levels, and I'm sampling and I find this contaminant X at much higher levels than I want. And I also know that there are industries nearby who are running private pumps, or there are people living nearby who get their drinking water from adjacent to these wells. I can look up the locations of these wells, do a spatial query, or look for nearby features. Say, what are these industries, who lives nearby? I can look up their phone number, their address, their email address. I can physically find them and go to their house and tell them, hey, don't drink your water. Right? This is a sort of cartoonish example here, but this is the type of capability you get from the GIS. Excuse me. Any questions at this point? Does it all kind of make sense? So we're breaking up the world into these layers that we can analyze and query together. There are two keywords I'm going to throw at you right now that I'll come back to over and over because these are really important. The two different types of models that exist for representing geospatial phenomena. These are the two models we use to represent the Earth. So the first format is what's known as the raster model. And so a raster is used to model things that vary continuously across the Earth. And what a raster is it takes some area and splits it up into a grid of uniformly sized cells, and each one of those cells takes on a value. And so this grid is continuous over some area. It's going to model things that vary over space without gaps. So an example of that might be an elevation raster. For each cell in this grid represents the height above sea level. So if you look at this as a whole, it's representing terrain and topography. So digital elevation model, or a DEM, maybe you're familiar, is a type of raster data set. Land usage, this is another thing that varies continuously. So each cell might represent, this is highly urbanized, this is moderately urbanized, this is natural forested area or agricultural field and so on. Right, so we have this grid of cells over some area. The vector model is our other way we represent the world. And the vector view of the world is for representing discrete entities. So things that aren't continuous over space, but that have, say, one coordinate to represent them, or a set of coordinates, and these take on the form of points. So maybe these are customers' houses. Maybe we want to represent the locations of fire hydrants, or maybe these are nesting sites, or specific trees, right? So these are just individual coordinate pairs, they're discrete. We can represent things that are discrete but linear using these sets of lines. So we're going to connect a series of points to make a line. So things like streets or rivers might be the example of a line data set. Or if these points enclose some area, we want to represent the boundary of something, we have these polygons. So these might be parcels, individual pieces of property. It may be a city district or a state boundary, and so on. Does that make sense? So what is the raster data model?
Continuous.
Continuous, yep. And what was it? What did it consist of?
Uniform grid.
Uniform grid, where each cell has some value. Right? So what was the vector data model? It's discrete. Yep. And what are the three types of geometry it can take? Points, lines, and polygons. Yeah, so we use that to model discrete data. In a GIS, or I should say, when we represent data to use in a GIS, I won't say that there is always a right or wrong way and choose to represent things. There's usually a better and worse. And you can convert vector data to raster data and raster data to vector data, but it's not equivalent. So let's go through some examples here. Think about the way the raster model views the world, the way the vector model views the world, and I want you guys to tell me what you think makes more sense for modeling this particular phenomenon. So our spatial entity here, our first one is hotels in Happy Valley. So we have the set of hotels. The raster view of the world is going to cover Happy Valley with a grid. And the cells that overlay these hotels are going to have a value that says, yes, a hotel is located here. If there's not a hotel underneath that cell, then we'll have not a hotel. The vector view of the world is going to set up some coordinate system, right? So an X, Y grid, Cartesian plane. And that's just going to put a coordinate pair, say latitude, longitude, to represent each of these hotels. So I'll give you a few seconds to think about which one makes more sense to you intuitively. And how many would say raster makes more sense to them intuitively? How many would say vector is more intuitive? Right. There's no right or wrong here. Just wanted to figure out. So for the raster group, why does that make more sense?
I guess seeing things out, like see the entire landscape and see where it's specifically. So maybe it's just an example of hotels and see where I think about that, but that's why intuitively it was just what I thought first.
Okay. All right. And for those vector people, who wants to make their case for vector?
Makes sense because the hotel's in the spot.
Yeah, it's
not like in this block somewhere.
right, exactly. So a better view in most cases probably vector, because What a raster is going to do is it's first going to set up this grid of cells, and if storage space on your computer is important to you, then you already need a larger file, where most of the information is just telling you a hotel is not here. There are certain types of analysis that may want your data in this format. Like if you need to, say, define Cartesian distances across some grid, this may actually be more useful to you. But generally speaking, the vector format is just going to say, here are some points where hotels are. How about ski lifts? There's ski lifts in Happy Valley. We want to map their locations and represent them. So again, a raster is going to set up this grid, and it's going to have cells where if that cell overlays it, it's going to say yes, ski lift. If there's no overlay, it will say no ski lift. With the vector view, we'll add points representing maybe these poles or something, and then connect them to form a line. So how many say a raster is better? Okay, and why?
I think for that one, the example will give you a better idea of the slope of the ski.
Okay, but again, all the information you have in this particular one is it's either a ski lift or not a ski. Okay, so with some overlay, we could potentially look at the slope of it, but all we know in this one is yes or no. So how many say vector? And why vector?
I guess for the very similar reason to the hotel is that you're either looking for a lift, so just knowing exactly what it is, not doing that data storage, or the lifts aren't as more intuitive.
Right. Yeah. Another thing to consider with a raster is each cell has some size associated with it. So it has, maybe it's 10 feet by 10 feet, 30 meters by 30 meters, 1 degree by 1 degree. And maybe the resolution of this raster is important to you. Is a ski lift generally going to be 30 meters wide? Or this is another thing, is the entity to be properly represented at the scale of your raster. Forested areas. I get usually an interesting mix depending on your background, but we could have forest areas represented by, again, these grid cells, or just have a polygon surrounding the forest. So how many would choose raster? How many would choose vector? Almost an even split. So raster people.
We're looking at a contiguous area.
Mm-hmm.
So I would think the raster would be more accurate or more easier.
Yep. Yep. And vector people. Why?
It tends to have sharper edges. A lot of times a road's an edge to a forested area that's hidden on the raster. So for us, it's just more accurate representation, especially doing research in those.
Okay. Okay. Generally, I find people who come from forestry have already looked at lots of, say, satellite or aerial photos of forests. A photo is a type of raster data, and they generally lean towards that for a forest. And especially if the cells, if we make this more complex, don't just say is a forest or not a forest, but maybe a type of species of tree, for instance. This is a very common format. For people who make maps of areas, like parks, maybe all they want to say is here's the edge of the forest. Here's the edge of the national forest on my park. Or maybe that boundary is all that's important to you. So the vector may be more appropriate.
Question for you. Yep. So if you did set that up in a vector model, you can still calculate area of the polygon in GIS?
So if you have data in a raster format?
No, if you're in the vector format, you can still analyze area within the polygon?
Yes.
There's tools for that?
Mm-hmm. Yep, and what we'll get into more next week is as you, when you create vector data of a certain format, it will automatically calculate that area for you in the units of the projection, which you can convert to whatever. Gotcha. I'll just go to my last example here, elevation. I've already said a common format for elevation is the raster. This elevation model where each grid is representing the height above sea level. Let's say we had a collection of points where we've actually gone and surveyed that elevation. We can do things like contour those points or actually interpolate, create a grid out of a set of points. Or we could sample a raster to create a set of points. That would be an example of converting back and forth between them. Any other questions? Does this all make sense? So, not always right and wrong, but better or worse. And when you're creating data, we'll get into the next workshop, you have to think about what is the phenomenon you're trying to represent? What's the best way to model it? Yeah, Jim pointed out, going back to the hotels, vector represents the location, but let's say you associated the size of each one of these cells to the hotel, and you wanted to know what area each of these hotels covered relative to other land use. That may be one way of looking at it. That's a good idea. All right. So I'll shift gears a bit and talk about the software that we're going to use for the majority of these workshops. Is Arcgis. This is made by the Esri company. It's the industry leader. People out there in the real world use it all the time. There are other alternatives. We offer some workshops on QGIS. Some that they use R. There are different software out there, but we're going to use Arcgis and specifically their desktop software, which is really a combination of 3 softwares together. 2 that we'll use today, and the Arc toolbox essentially lives in the background. So what we're going to do is look at this Arc catalog first. This is what we use to preview and manage our data. Arcmap is the program you probably think of when you think of a GIS. This is where you actually pull data together, change their symbology to create maps and perform analysis. There is, through an Arcgis account, this family of different software. And we'll take a look at some of these. There's Arcgis Online, which is a cloud-based version of the software. You can access it just from a browser. There's nothing to install. There is a new version of Arcgis called Arcgis Pro, which we'll move to in the next year or so. There are server versions of Arcgis, so you can serve out data to your organization. There's mobile GIS. We'll do some stuff where we take our smartphones and go map things in the field using the Selector application and Survey 123. And there's also data that lives out here on the cloud that you're able to, say, create an Arcmap and send to Arcgis Online or to Collector. Or you can pull data out of the cloud into Arcmap. All these things sort of live together, linked to one another. But today we'll start with Arc Catalog and Arcmap. Any questions on the software? We have, we purchased a big license, so we have pretty much every Esri product available to all of you here at Clemson. And like I said, we'll show you how to use Arcgis Online and some of these mobile apps in upcoming workshops. Okay. If there are no other questions, we're going to start doing some hands-on stuff then. The first exercise we're going to do is previewing data. We're going to start by using Arc Catalog. So we want to take a look at what geospatial data look like on a computer. How can we preview them before we ever pull them into a map? How can we learn more about the data? See what's inside of it. We also use Arc Catalog to do things like copying and pasting data, renaming and deleting data. And I'll show you examples of why that is. And then I'll do that by showing you what it looks like through Windows Explorer and Arc Catalog, so you see the difference. So if you would like to follow along in the tutorials, they are, once again, if we go to that Windows Explorer, that folder icon in the lower left corner, and we're going to navigate to the D drive, that Data 2 drive, to the Introduction to GIS folder. So again, if I open Windows Explorer here on the left under where it says Computer, I'm going to go to D, Data 2. Your data drive will look a little different than mine, but we're looking for Introduction to GIS folder. And within that folder are the handouts. And we're going to start with this one, GIS, Fundamentals Intro to GIS 1, Previewing Data. And so if you like, you could have this up on your second screen next door. So let's work in that Introduction to GIS folder and open that data folder. And within that, you're going to see all sorts of stuff, right? So there are some, whoops, I want to sort by name. Looks like there are these folders, energy, this folder called energy.gdb, a folder called political, a folder called political.gdb, South Carolina 50-meter wind, a bunch of stuff with the same name repeated a bunch of times, right? What are these things? Let's also open Arccatalog. So from the Start menu in the lower left corner, we're going to go to All Programs, to the Arcgis folder, and open this one, Arccatalog 10.5.1. So we're going to open Arccatalog, which is, again, this program. We're going to preview data. We're going to manage our data with it. It's sort of like the Windows Explorer here, where you can navigate to different locations on your computer, but it's specifically for GIS data. It'll probably take a minute to open on this machine. Whenever I need something right away, it always takes 2 or 3 minutes on the computer. But Arccatalog is, the name comes from the days of yore, and I'll say that tongue in cheek, where libraries had a card catalog that you actually had to flip through to find things. Arcgis, the company was started in the late 60s. The software, I don't know when it started, I believe in the early 80s. So it's taken on a lot of different forms over the years. With Arccatalog or Arcgis Desktop being one of the more modern versions. Okay, so now I've got Arccatalog open and my Windows Explorer here. Does everybody have Arccatalog open? Okay. Does anybody see something on the very left side? What I need to do is hover my mouse up here at the top where it says Catalog Tree. I'm going to click on that. So does everybody have the catalog tree open here on the left? So you see these things. The first one is called folder connections, toolboxes, database servers and connections, GIS servers, and so on. So these are different locations with different types of GIS stuff. The first thing we need to do is tell the GIS software where our data live. We need to define a file path so it can go and find it. And we do that by creating a folder connection. So here at the top of the screen, the top left corner is this folder with a plus sign icon, connect to folder. So if we click on that, we can navigate to a folder, and our data are stored in this file path of D, data 2, introduction to GIS, and the data folder. So we want to navigate through this menu. I'll expand the computer, expand that data 2 D drive, find that introduction to GIS folder, and expand it, and then click on data. So my file path is D, introduction to GIS data. Everybody there? For those of you remotely, that will just be the file path on your local machine that you've saved to. So now I'll click OK. And I forgot to disconnect it from when I was playing around this morning. and I had it twice. But you can see now under folder connections, if I expand that in the catalog tree, if I click that plus sign on folder connections, all of these machines have two default connections, this ArcTutor and this Last Tools. But now we have this Introduction to GIS data. And if you expand that, you hit that plus sign next to it, you can see all these folders within it, right? So there's that energy folder, that political folder. Now there's this energy.gdb thing that looks like a soup can. I tend to think with my stomach, and everything in GIS looks like food to me. So I have these energy.gdb soup cans. I have these two waffly looking things, one the Clemson Topo 1951. There's this chocolate chip cookie green thing, TRI facilities. I also see a slice of pizza, or a pizza of the USACE reservoirs. Okay, so what are all these different things? Storm's getting ahead of us here, right? So notice as I click on each of these folders, say click on that energy folder in the catalog tree, here in the contents panel, I see this list of things that all have green icons, they have names. If I expand that folder in the catalog tree, yep. Okay. So, that's all right. So again, if I expand this energy folder in the catalog tree, I see this list of green things. I can also see in the contents panel, these green things there have a type, a shapefile. How many of you have heard the word shapefile before? A number of you. All right. Now, if I go to this energy.gdb, if I click the plus sign next to it, I see that there are also things within it, just like a folder. And some of them have plus signs. I can expand them. And if I look between the two, I see this HGL Pipelines US 2016 in my energy folder. I also see something with that name in my energy.gdb. So what's going on here? I'm going to switch back to my PowerPoint for a minute. These are just different formats of geospatial data, right? And I have two different categories here. One, I'll put in air quotes, individual files, and then also this file geodatabase. So an individual file is something that lives on its own. And an example of that would be a shapefile. A shapefile is a file type that represents vector data. So it can be either be points, it can be lines, or it can be polygons. A shapefile will only have one type of geometry, so you wouldn't have points and lines in the same shapefile. It can represent or store polygons, lines, or points. And the shapefiles have a green icon. Actually, any individual file has a green icon. So those things that look like chocolate chip cookies were a shapefile. We can also have individual rasters for these waffles that I was talking about. We can have tables. So these might be Excel tables, Microsoft Access tables, a number of different formats. And then these map documents. We'll talk about these a little more later, but the map document is an individual file. So going back to our catalog for just a second. I'll pull that here. So within that energy folder, we had all these different shape files. And notice that some of them have those chocolate chip cookie icons. Some of them have a different icon. The one I said looked like a pizza. So what do you think each of those different icons is telling you?
I was going to say what type was shape file?
Right. So the chocolate chip cookie, what do you think? It's points. Yep. And we could have lines or we could have polygons. So again, these are individual files. They're limited in size up to 2 gigabytes. And shapefiles kind of came around in the late 80s, early 90s, when 2 gigabytes was the size of your entire hard drive. Right? So that seemed like a pretty good limit. At some point, probably the day after they invented shapefiles, they realized, well, actually, we need a lot more storage than that. And I'm kind of joking here, but a file geodatabase is a different data architecture that can represent and store data the same way, but it's much more efficient for a computer to operate and work with. So a geodatabase, you could think of like a folder or a container where it has all these different data types that live within it. So it can store a number of individual vector data sets, but it calls them feature classes. So these look a lot like a shapefile, and they represent or store things as points, lines, or polygons. But now you see them, they have these blue icons, or bluish gray icons. So you can think of it as a feature class as a shapefile that lives in a geodatabase. You can also have rasters that live in a geodatabase. You can have things like network data sets, topology, or these sort of rules about how geometry interacts, and things overlaps, and so on. You can actually combine feature classes into a feature data set. So people who manage large amounts of GIS, say at the county level, usually have feature data sets that group things like transportation, or land use, or parcels, or whatever. But all of these things in a geodatabase get written together in a way that's efficient for the computer to read, but they're not individual files anymore. I can't open up a geodatabase in Windows Explorer, grab a few files and copy them and send it to my colleague. With a shapefile, you can do that. But with a geodatabase feature class, you need to export them out of the geodatabase to a shapefile. And I'll show some examples in a few minutes of what that looks like. Does that make sense? Any questions on these? So again, we have our individual files and shape files that are green, individual rasters, or we could have a geodatabase that stores these within them. And there's no limit to how large the data can be within this geodatabase. So if you need to store hundreds of thousands of points or lines or polygons, it's much more efficient to create them as a feature class in a geodatabase.
So what's the difference? So the geodatabase, is that referencing a shapefile, or is it pretty much a shapefile within a geodatabase?
Okay, I'll pull it up right now just so you can see. I'll go back to Windows Explorer where you can see the difference. So notice in my energy folder here in our catalog, I have that HGL pipelines.shp, that shapefile. Within my energy folder, through Windows Explorer, I actually have 7 or 8 files that all have the same name but a different file type. And this collection of files is interpreted by GIS as one shapefile. This is why I put individual in quotes. A shapefile is a collection of files that work together as one unit. And to interpret them correctly, the software needs all of those pieces. So if I copy and paste 7 out of 8 of these to another place, and I miss one, GIS doesn't see a shapefile. It won't find it. Does that make sense? If I go into a geodatabase, though, notice my energy geodatabase has these feature classes within it. If I open that energy geodatabase, I see a lot of things with all sorts of indecipherable names. The data within the geodatabase are written across all these different tables and files and whatever together. So the software can interpret them as a feature class, but I can't just select, say, these files and export them and have it represent anything.
In your Windows Explorer for the shapefiles, none of those individual shapefile components is like a table or a database. Like you can't like email somebody the CSV of the underlying points.
They are actually, like one of them, like the .dbf is the table in the access database format. The PRJ tells you the projection or coordinate system of the data. The .shp gives you the geometry or the actual coordinates in that projection. But you wouldn't want to copy one part of a shapefile and send it. There's still going to be issues.
Is there a specific reason why they split them into multiple files instead of just writing them as one larger file?
I'm sure there is, but I don't know what it is. I think that was just the way that they were able to combine these different file types together into something used by GIS. Great questions. All right. So what I want to do, though, is let's go back to our catalog, then. So we've been looking at things here in our catalog tree, which, again, is how we're going to create folder connections, define data. But let's click on this, expand the energy folder, and click on those HGL pipelines shapefile. And now click that preview tab at the top middle of the screen. So the preview tab is going to show you what's inside the data. And notice here at the bottom it says preview geography, which will show me the geographic part of it. And so here the pipelines look like a plate of spaghetti, or here these actually look more like something approximating the United States. So as I click around on different shapefiles or feature classes, I can see that your guesses were right. Things that had that chocolate chip cookie contain points. The things that look like pizza, to me, were actually polygons. So what I can do is I can preview any of these data sets. I don't have to add them to a map to see what their geographic extent is, for instance. I can know right away, well, this one looks like it covers South Carolina. The other thing I can preview here at the bottom left, once again, from the geometry is switch to a table. So this is the other component of a geospatial data set, is that it's this database of information where that we have a description of the geometry, whether it's point, line, or polygon, but each one of these points, lines, or polygons has this attribute information, all this data about what it is. And this is the other really powerful and important part of the GIS. So each of these polygons has some attributes that has an ID, a WPC, and then this length and area. Right? So each of these polygons has a length and area. And as I click on different shape or feature classes, let's say those petroleum refineries, I can see all sorts of information about each one. The company or corporation that operates it, the site, a whole bunch of stuff that I don't know what it is, quite honestly. This is where you can go to preview those attributes.
Where's the preview there? What file is that?
So down here at the bottom, where it says preview, at the bottom center, it will say geography. You can switch it to the table. So you can also do things like sort. So if I go to my petroleum refineries shapefile and preview that table, let's say I wanted to sort the company name alphabetically. I can right click up here along the top where I see the name of that column. So right where it says company, I can click and I can do things like sort ascending, and that will interpret it to sort them alphabetically, or I could reverse it and sort descending. I can also freeze or unfreeze the column just like you can in Excel. So if I have a very big database here, a lot of attributes, and I want to see the company as I scroll through, I can freeze that column to the left. And if I right click on it at the top, I can also unfreeze it. And now if I switch back to my geography, I can do things. Notice these at the top, there's the a magnifying glass with a plus sign. This is a zoom tool. I can zoom in by clicking this magnifying glass with a plus sign and clicking somewhere in the data. I can also click and drag a box to zoom into that location. I'll switch my data set here. I can use that magnifying glass with a minus sign and click to zoom out. If I get totally lost, there's this globe icon. That's the full extent, and it will just zoom you to the extent of your data. And then there's this pan tool, the Michael Jackson gloved hand at the top. And if I click on that, I click and drag my data around. We'll change the location without altering the zoom level. You can also do these things with the mouse wheel without accessing the tools. If I roll the mouse wheel away from me, it will zoom out. If I roll it towards me, it will zoom in. And if I click and hold that mouse wheel and move my mouse around, I can pan my data. So I can zoom in and out and pan around without selecting those tools. All right, so does everybody see an example of a raster here in my catalog tree? So far, it seems like we've been looking just at vector data. I'll click on this Clemson Topo 1951, that waffle. And I see a .tiff file extension. So common image formats like TIFF and JPEG are interpreted as raster data sets because they're just a grid of styles where each style has a color associated. If I zoom in on this data set, I'll notice this is just a scanned USGS quadrangle. And if I keep zooming in further and further, I can see the resolution of that grid. So you can take paper maps, you can scan them into a digital format, and what we'll do next week is georeference this, or actually assign it coordinate information. Notice in the lower right corner, as I move my mouse around, it's giving me a latitude and longitude, right? Decimal degree. So it's giving me a location information for my data. Questions? All right. The other thing I want to show you, let's preview, is metadata. How many of you are familiar with metadata? What is it?
Data about data.
Data about data. So what do you want to know about a data set? Let's say you're trying to find data for your thesis. And what do you want to know about this data? If you're going to stand in front of your committee and have them grill you about where your data came from, what do you want to be able to tell them? How it was measured or collected? Absolutely. Who created it? That's one of the first things I want to know. When was it created? What's the resolution? How is it, say it's a physical entity, how was it measured? Has the data been processed? At what scale was it created? Is the data appropriate for my scale? If I'm mapping at, say, the county level, do I want something at the continental level? Maybe not. So the other tab here at the top is this description tab. And this will show you any of the metadata associated with it. So our Clemson Topo raster data set has nothing in it, no information. We don't know where it came from. We don't know who made it, when. But click around on some of these other shapefiles or feature classes. For instance, the HGL pipelines tells you that they're from June 2016. These are the major HGL pipelines in the United States. Tells you what these data represent. It tells you that the Energy Information Agency holds no accountability, so on and so forth, but it gives you the extent of it. Right? So some of these have very good metadata that tells you a lot about who created them. For instance, this tells you it's wind power class modeled at 50-meter height. Some of them have no metadata in them. And so a good GIS professional, when they create data, also fill in the metadata associated with it. So if you need to share it with somebody, they have that information. One thing I want to show you, though, let's click here at the top where it says Customize menu, and go to Art Catalog Options. So again, I went to the Customize menu here at the top, click on Art Catalog Options, and click on this Metadata tab. So the metadata style we're looking at is what's called the item description, which is just a basic summary. There are different metadata formats with standards associated with them. A very common one is this first FGDC CGDSM metadata. So let's select that, click apply, and then click OK. And then click on a different data set than the one you were previously. And now you'll notice that there are all these other fields that have been filled in or not, depending on the data set. So for instance, this tells you all the different fields in the attribute table, their name, an alias, which is like a nickname, the format, and oftentimes there are definitions associated with them. Because some shapefile limits the number of characters you can name a field or that column. And sometimes you get very cryptic field names out of a shapefile, and you need to go to the metadata to learn what each of those mean. So we have our contents tab, our preview tab, where we go to view the geography and the attribute information. And then a description gives us the metadata associated with it. Let's see, I'm going to go back to my presentation and like I forgot a slide earlier, but talking again about our shapefiles versus geodatabases. So we've seen that a shapefile is this individual file, right? A collection of them that live together. We're limited in size to 2 gigabytes for the file size. The field names have to be less than 10 characters. They're larger on your hard drive than a file geodatabase will be for the same amount of information. So we recommend you create file geodatabases and feature classes within them for storage. Because there's no limit to the size, there's no limit to the number of characters you can use. It will automatically create and update the area or perimeter if you're interested. And they're faster in terms of efficiency. If you're doing a lot of querying against it, you get much better performance in the geodatabase. So why would you want to use a shapefile? If you need to export it to other software and it only takes a shapefile, you can export something out of a geodatabase. Or if you just want to share one part of that geodatabase with a colleague, you can just grab those files, zip them up together, and then email it to your colleague down the hall. Or if you just need a very simple geometry, a shapefile will work for you. The other thing I want to show you then is we've previewed data, but we use ArcCatalog to copy, paste, and rename data. So just watch what I'm going to do. Don't replicate it so you don't break data for later on. I'll just do it myself here. But I'm going to open ArcCatalog, and I'm also going to open the Windows Explorer. And I'll go to that energy folder to this HGL Pipelines US 2016 shapefile. I'm going to right-click on it. Again, don't do what I'm doing, just watch. So I'll right-click, and I can copy, rename, and delete. If I copy this and now just paste it to a different folder, and I refresh, notice there's the copy of my shapefile right away. And then I also see within this folder, it copied and pasted all of these files together. And now if I rename that shapefile from here, again, don't do what I'm doing, just watch. And I'm going to call this pipelines _ rename. Notice that it updates the name of all these files together. And if I delete that shapefile, it will delete all of these together. So I'll do that now. Notice I used an underscore and not a space. GIS software is very picky. It doesn't like spaces in file names. You can get away with it sometimes, but things will often break and you don't know why. And it can often be that there's just a space on it. So it's deleted all these files all at once together. Right? So this is why we want to use ArcCatalog to copy, paste, rename, and delete data. If you copy 7 of those files or rename 7 of those files, and the 8th one doesn't get renamed exactly the same way, the shapefile will break. We'll do this a little more later, but you can right click on our energy geodatabase. You can do things like export a feature class to a shapefile, or you can import shapefiles into a feature class. So going back to that energy folder and the energy geodatabase, all of these things, all these feature classes have the same name as the shapefiles because they all started as shapefiles that I brought from them. Or maybe they all lived in this geodatabase and I exported them. It's been a little while. They're equivalent in terms of what they contain. They're just different formats for the data.
Like I got a question.
Yep.
You only edit metadata in catalog, or can you do it?
It's done through catalog. Mm-hmm. You may be able to do it through catalog and Arcmap, but I've never tried.
Yeah.
Catalog would be the program you go to. Any other questions? All right. So let's move to our next exercise then. Let's make a map. Let's do something with our data. So we're going to open the Arcmap software, pull in some data, and I'm going to show you some of the tools and the interface and how to do basic stuff within Arcmap. So what we'll do is go to the Start menu, go to All Programs, to ArcGIS, and open Arcmap 10.5.1. And if you're following along in the handout, I'm going to start the next one, creating a map from scratch. So I may not follow this exactly. If I do something different than the tutorial, don't panic. So again, Arcmap is the software that you use when you want to actually work with data. Once you've, say, previewed it, seen its extent, looked at the attributes and the metadata, this is where you go to pull it in and actually make a map out of it. So combine data together, perform analysis, export data to a printed map, and so on. So you're going to get a Business Analyst Desktop Message Center window pop up at you. Go ahead and close that. And here's my software. So here's the Arcmap window. It looks a lot like our catalog, but now here on the left, we have something called the table of contents. This is where data sets within the map will show up. It will show you what's stored in the map. We have some of these toolbars. You can see the zoom tools, once again, our magnifying glasses. This central part is what's called the data frame. The data frame is your canvas, where you're going to add data and work with it. See it all happen here. And the data frame has a specific icon. Here's another food name for you. It's these Kraft singles slices here in the upper left. And the default data frame is called layers. Very, very boring. So you can also see there's this business analyst network barriers. This is just on our machines here. We can right click on it and click on remove. We don't need that one. So what I've shown you is the key to 95% of the questions you'll have when using the software. How do I do something? Try right clicking. The context menus in ArcGIS are everywhere. And as you right click on different things, you'll have different contextual menus based on what it is. So if you're trying to remember how to do something in the future, just try right clicking till you find it. So we have our blank data frame. We have our table of contents here on the left. What we want to do to start with is we're going to add a base map. And a base map is a pre-drawn map that's available in the software. A lot of them are thematic. They may be streets, they may be political. There's an aerial imagery, different more artistic styles. To add a base map, we're going to click the triangle next to that plus sign here at the top center of the screen where it says Add Data. So now if I click that drop-down arrow, I have a couple of options to add data. The second one is Add Base Map. Let's click on that. Again, the drop-down arrow at the top, click on Add Base Map. So you can see these different options. Let's just grab the topographic one. We'll click on topographic and click Add. And if you get this warning about hardware acceleration, please click No. On our machines, they're not set up for this, and it will just cause Arcmap to crash and lock up on you. So click No where it says hardware acceleration. So here's my base map, my topographic base map. Now I can see it's added to the table of contents. Under the name of the data frame, which is layers, I see this base map. We can check a box next to any of these layers to turn them on and off. So if I uncheck the box next to base map, I can turn that layer on and off. And I remember I have these zoom tools available through my mouse. Right, so let's say I want to zoom in to the United States. I can use my mouse, I can zoom in, and I can pan by clicking and holding that mouse wheel and drag around. And then notice this box here at the top, this 1:20 million, which changes as I zoom in and out. What is that number?
Yeah.
The scale. And what is the map scale? Storm, you know.
What is it or what is it?
Yeah, what is a map scale?
The relation, so it's 1 unit to whatever the other.
Right, it's the relationship between the size of something in my map to its size in the real world. So one thing, it's unitless, one thing in my map on mine is equivalent to 20 million. So whether that's inches, centimeters, feet, whatever. And as I zoom in, that number will get smaller, 1 to 6 million. And as I zoom out, it gets larger. All right, but what I want you to do is just use those tools to zoom in to approximately this view. And we're going to save this view by creating a bookmark. So here in my bookmarks menu at the top, I'll click on bookmarks and then click on create bookmark. And what this will do is allow me to come back to this area and this scale instantly. So it asks me for a bookmark name. I'm just going to call it lower 48 and click OK. So now if I pan to a different location and I go to my bookmarks and click lower 48, it takes me right back. I used GIS for several years before I learned about bookmarks, including a summer job where I was scrolling back and forth between 2 plots in Voyageurs National Park about 8 million times an hour. This would have saved my life. But so it's very useful. I'll let you learn from my mistakes. But let's also create a bookmark for South Carolina. So let's zoom in using some combination of tools till you have something like this. So we can see South Carolina nicely. And let's create another bookmark. So again, I'll go to the bookmarks menu, go to create bookmark, and I'll call this one SC. And now I can go back and forth between the lower 48 and South Carolina instantly. Another thing I'll point out is here at the lower right-hand corner, there are those coordinates again. So anywhere my cursor is within the data frame, I see those coordinates. And those coordinates will be in the coordinate system of whatever data got added first. We'll talk more about coordinate systems next week, but you can see these are our projected coordinate system. They have a linear unit, which is meters, rather than an angular unit like degrees. Does everybody have those 2 bookmarks? All right, so let's add some other data to the map. I'm going to go to my lower 48 bookmark. And now let's add data. The first way I'm going to show you how to do this is adding it from the Arc Catalog program. There's probably 5 or 6 different ways we could do this. So I'm going to show you Arc Catalog again. And if I click, I'll move Arc Catalog over a bit. You can put them on the screens next to each other. But I'm going to expand my political geodatabase here in Arc Catalog. So I'll go to my political geodatabase, expand it. Arc Catalog is going really slow for me. There it is. And I'm looking for this feature class called US State 500K. US State 500K. And now if I click and drag, if I click and hold the mouse button and drag it into the data frame, you can see my cursor gets a plus sign next to it. And if I release the mouse, it will show up here in my table of contents under the word layers, and it'll also show up in the map. Was everybody able to do that? All right. So what kind of data are these that we just added? They're polygons, which means they're vector. Yep. And so these polygons represent the borders of states in the United States. They get added with some default color, whatever Arcmap chooses for you, so yours may be a different color than mine. But you can see here in the table of contents, there is the name of it, and beneath that name is a box that shows you the symbology. We'll get into symbology a bit more in a minute. So let's add some other data to the map. The next way we'll do this is we're going to expand an Arc Catalog panel from within Arcmap. So we can access Arc Catalog here on the right side of Arcmap. You should see a catalog, or from the top, this toolbar near the scale is another catalog. So if I click that, oops, I clicked the wrong one. I'll have catalog open on the right. And there's also this push pin in the upper right corner to auto hide. I'm going to click that push pin and keep Arc Catalog open all the time. And so if I expand the folder connections here, I see that same folder connection I already created for the Introduction to GIS data folder. And if I expand that, I can go navigate again to the political geodatabase. May take a minute for it to catch up. Expand that political geodatabase, and I'm going to grab USA Major Rivers. So I'll click on this USA Major Rivers feature class and drag and drop it into the map. And the next one I'll do is the USA Major Cities. And I'm going to do that the same way. So I'll click and drag USA Major Cities into the map. Everybody there?
Where's the USA Major Cities?
It's in the political geodatabase. So if you expand that, it's here near the bottom. Everybody have those?
No.
Not yet.
I don't have any. I South Carolina.
You're in the shape.
Oh.
So I have a map right now that looks sort of like the United States has the chicken pox. And hopefully you have something similar. So again, I can check and uncheck boxes here in the table of contents to turn things on and off. I can also reorganize the order of things in the map. So the way the software works is it will draw whatever's at the bottom of this list first. So in this case, it's the base map.
And then it will draw each layer successively on top of them. So next it does the states, then the rivers, and then the cities. So I can click and drag and drop my USA major cities from my table of contents. Notice that as I move it around, there's this thick black line that shows up. These are different places I could drop it. So I'm just going to move it beneath my states. And I see that it does what I expect it to. It's now drawing it underneath my states and rivers. Cities at the border I can still see peeking out. And I can click and drag and drop it back at the top of the list. And so I can reorganize my data. Any questions on what we've done to this point? Everybody here have data in the map? All right. Yep.
Any other benefits besides visually having a base map, like this whole world base map? Because you, like, let's say we have the USA 500K atlas map of the United States. Do you need a base map?
No. So base maps are common and they're really useful because they often they're an easy way to give context to data. So if I were just showing rivers, maybe I want some supporting information to give them context. Base map is an easy way to do it. Up until a few years ago, you had to supply your own base maps. So these were often a scanned paper map or an aerial photo or something, or just a collection of data that had been synthesized. But these are a really fast way to do it. So you don't need to use them. They're just something I add all the time. Most GIS people do. All right. So another thing I want to show you then is, let's say I want to open the attributes for my states, for my cities. I can do that from Arcmap. I can work with those attributes just like I did in Arc Catalog. So any guesses how I'm going to do that? Right click. What am I going to right click on? Sure. Let's see what happens. I'll right click on USA Major Cities. And my third option from the top is this Open Attribute Table. So here I have a table that opens up in the middle of the screen. If I click on it and move it around, do you see these blue things that show up? These are different places I could dock a table. And so I'm going to drag it to the bottom center down here, and release the mouse on that blue thing. And it will dock it across the bottom of my screen. So here I see my USA major cities. Looks like all sorts of information. What sorts of data do we have for our cities? What do you see in the table?
Time zone, elevation.
Time zone, elevation, yep. Latitude, longitude, names, states, populations. So there's all sorts of data we could map here. We could make a map out of all sorts of different attributes, right? And we could say map population by changing the symbology of our city. And that's where we really start getting into the power of GIS to communicate a message through a map or tell a story. Let me check my tutorial, make sure I didn't miss something. All right. So this is where we go. We can open our attribute tables. We can also close them. If I click this X in the upper right corner, and I can go back by right clicking and opening that attribute table at any time. How do you undock? Undock, if you click and drag it out of there, it will release itself. All right. Any other questions? Let's take a break till 40 after. So about 11 or 12 minutes. Stretch your legs. There are restrooms just outside the door here in the hallway or near the main entrance of the libraries. Depending on the lines at Starbucks, you may be able to go grab a cup of coffee upstairs on the 5th floor. But we'll meet back and get started at 40 after.
I encourage you to go check out our collaborative space next door. There's an augmented reality sandbox, which is really cool to check out. All right. All right. Did everybody get a chance to sign in?
Yeah, just,
All right. Good. I think we might still be missing a person or two, but I'll go ahead and get started. I'm going to start with a quiz. And if you get one wrong, you're banished forever. You never come back. Just kidding. Just want to check in and see if the concepts have stuck. I've been talking a lot up here, but this is really the foundational stuff. So what are the two primary categories of models we use to represent the world in geospatial data? Vector and raster, and describe the vector data model. Points, lines, and polygons, it's discrete, so it models discrete entities that we can represent with coordinates that are either points, or we connect the coordinates to form lines, or bound areas with coordinates to form polygons. How did we tell Arcgis where our data were located on the computers?
Connect folder.
Yep, we added a folder connection, the first thing we did. So if I go back to my Arcmap software, I can open our catalog from Arcmap. I can click that folder with a plus sign icon to add a folder connection. I can also right click on my folder connections and click on connect to folder. All right, so just another example of right clicking being the thing to do. What is the data frame? Where is it located? Let me pull up Arcmap down here. Which part of Arcmap is the data frame? Point to it. The big part. Yep. This thing here where we actually build the map is the data frame. And so the data frame has a table of contents. We add data to it. And again, those craft singles icons, those yellow squares, represent a data frame. A map document can have multiple data frames within it. And that may make more sense when we get to the layout view. How did we add a base map? Yep, here along the top was that plus sign with a little triangular arrow. We went to add base map. We can also add data to a map this way. The interface is one where you have to navigate directly to a data, a file of some sort. I find that is less convenient than adding from Arc Catalog. I almost always have Arc Catalog open as I navigate through my data. And I probably have, 25 folder connections in Arc Catalog on my computer right here. What is the scale of the map? Both conceptually and where is it in the program? Easy question first. Where is it in the program? Top, probably top left or top center, right? That's that ratio between the size of something in the map and its size in the real world. This ratio between the two. And how did we see the attribute table of a layer? Here in Arcmap, where did we go to open an attribute table and view it? Yep, right-click in the table of contents on its name, and then go to Open Attribute Table. All right. Excellent. So our next exercise, we're going to move more into symbology, the actual map making side of things. So we have added data. These data have some geography. They have some attributes. How can we actually map those attributes, make a map of something, show how something varies across space? How do we communicate some sort of message? The way we do this in a map is by changing the symbology, using attributes to drive the way we represent data. So we'll change the feature symbols, which is the easy way to change symbology, but we're really going to focus on using the attributes to define it, as well as demonstrate a few other tools. So I'll drag Arcmap back up here. Let's save our map. right now, let's click File in the upper left corner and then click Save. And we're going to save this map by clicking in the computer here on the left of that dialog. Going to that Data to D drive, double click on that. I'll scroll down to that Introduction to GIS folder. And we'll just save it in that Introduction to GIS folder. And we'll give it a name. We can call it map_1_ with your name or your initials. I'll put BAL for my initials. And you can go ahead and click Save. Notice it's going to save this Arcmap document. This is a file that has an extension .mxd. So if I save this, now if I go here in my Arc catalog panel on the right, I'm going to right click on that Introduction to GIS data folder. Oh, no, it won't show up. We can refresh, where anytime you make changes, you can refresh it. I just saved it in the folder above it. That was my mistake. I'll pull it up here in Arc catalog. Here's that map1 BAL, this map document. So a note about these map documents, it's essentially just a text file that says, here's where the data live on this computer, and here's how to draw them all together. It's really just a set of instructions. Your data do not live in this map document. And if you move the map document relative to where your data are stored, it will not know where to find them anymore. I'll say that again. If I were to copy and paste this map document to a different folder and then open it, I would not see any of my data show up other than the base map because the file path between the two has changed. So this is just a set of instructions. It does not save any data in the map document. Your data still live wherever they're located. So they could be on a local machine. They could be on a server in a different state or country. These are just instructions. If you click the File menu and go to Map Document Properties, there's this checkbox here at the bottom next to the word path names. If you check the box to store relative path names to data sources, I'll click OK. Now, if I copy and paste my map document and my data to another location, as long as the relative path between the two is maintained, it will be able to find them. So let's say I save my map document and say a folder is my data. I could copy and paste that folder from place to place. So this will make more sense if you've done this and made that mistake before where you open a map document and it will show up as all these red exclamation points and nothing will be in it. And you'll think, where's all my data? Where's my map? That's what happened. So I've done that plenty of times. Again, learn from my mistakes here. All right. But what we really want to do now is focus in on the way we're symbolizing our data. This map we've created so far doesn't tell a whole lot, except here are some states, some rivers, and some points representing cities. It's a bit boring and not all that attractive in terms of something that's nice to look at. It's very easy to make a bad looking map in GIS. Almost anybody can come in and do it in a few minutes. It's an art and a science and a skill to craft a map that is easy to interpret without any additional information that communicates the message you want it to, as well as something that's visually appealing. And so it's the whole branch of cartography that focuses on this. So we'll start our cartographic journey here by, let's just play around with changing the symbols, starting with these cities. So if I go to my table of contents over here on the left, there's this little diamond underneath the USA major cities. If I double click on it, it's going to open the symbol selector. And this is a way I can change the symbol used to represent my cities. So for instance, if I just click on, let's say I want to change the color. I can click that color menu, choose, I don't know, a color you like. Bright green, maybe I want to make them a bit bigger. up to 6 for a size. That's the size in points. And then I'll click OK. And it changes all of those right away. If I double click on that over here in the table of contents to open the symbol selector, you can also search for particular symbols. So if I type the word city, it will search through all the different styles on my computer. Let's see, there are some 3D buildings, there are some cranes. There's this one under the civic option called city. I'll just go ahead and click on that. Right? How many of you like this map right now? Say, this is a nice looking map. We're done for the day. Now, but I just show that you can use different types of symbols that are available to you. For instance, if you work in geology a lot, we have, if I search for strike, I think we have the geology 24K on here. So we have strike and dip symbols. If you're a geologist, there's a number of different categories. So you can always go and search. You can change the size of any of these things to your liking. Say I wanted to make these bigger, and now if I switch to my SC bookmark, notice that the size of the symbol hasn't changed with respect to the map document. It'll appear bigger in the real world because that size is the size in points. And it will maintain that size in points as I zoom in and out. I'll go back to my lower 48 bookmark. So go ahead and choose, I'm just going to go back to circle 2. I'll just pick a color for now, maybe a medium blue, 9 points. Just something plain that you think looks nice. We can do the same thing for our rivers. If we double click on this line here in the table of contents, we'll get a symbol selector. But now my options are all types of lines. And there is already an option for a river here in the lower left corner. I'll just select that. And then if I go to my states, here in the left in the table of contents, double click that box. I can see all sorts of presets. I can give them a color. I can make them hollow, which means that there's no color, just a boundary, which is often really useful feature. But I'll just give them some color, maybe a very light blue. I like blue. So it's very easy to just change all of the symbols all at once. And for some types of data and some types of maps, that's fine. Another way we can access this is, let's right click on our US state 500K layer. And near the bottom is the properties. So again, I'll right click on my US states 500K, go to the properties. And this has all sorts of tabs. There's all sorts of things we can do to our data through the properties. You can see there's source, selection, joins and relates, display. What we're looking for is symbology. And this is where we go to, we can access that symbol selector again, which is here, or we can link attribute information back to our data. So notice on my layer properties on the symbology tab, the default is to show, and here on the left it says features with a single symbol. That's the default behavior when you add a data set. And if I double click on this blue box, it might be a different color based on what you have, it will open that symbol selector once again. There's another way to access it. But there are lots of different types or methods of symbolizing our data that we could use. So let's just click OK without making any changes to symbology yet. And let's open that attribute table for our cities layer. So I'll right click on my USA major cities, open that attribute table, and take a look at those attributes and think, is there some attribute in there that you want to use to make a map out of? What is an attribute we could map? We could make a map of the name. What would that look like?
A lot of names.
A lot of names. Do you mean we could add labels?
Yeah.
Yeah, we could label these cities with their names, but if we want to link an attribute to our symbol, the symbol itself, maybe we want to change the size of a symbol or the color of a symbol, or maybe some combination of those. Is there something we could use? Population, absolutely. So there are all sorts of population fields in this table. We will use this one called pop_max. Again, notice that we have an underscore, no spaces in the field names. They're not allowed. So we're going to use pop_max, and we're going to map that attribute. So I'll close my attribute table. I'm going to right-click on USA Major Cities again and go to those properties. And now if I go to back to that symbology tab, let's click on categories. So we could draw categories, draw our symbols using categories, which is some sort of qualitative measure. So things that either have a different value of a specific type. But what is population qualitative? It's quantitative. So we want to map a quantity. And our first option here is a graduated colors. And so what this will do is it will read through all the values in that attribute field, and it will vary the color of these points based on the value for each point. And we tell it which field to look in this value dropdown. So here in the middle, where it says draw quantities using color to show values, it says value none. We want to click the drop down and select pop_max. And then we'll click apply. And I'll move my layer properties a bit so you can see. So what does it look like now in the map?
Where did the layer property window come from?
Mm-hmm. So I right-clicked on my USA Major Cities layer in the table of contents.
Right.
And down near the bottom is the properties. Yep. And then I went to the symbology tab. And here on the left, clicked on quantities. And so we've got graduated colors highlighted. And in the value field, there in the middle, I went down and selected pop_max. And then clicked apply. So right away, you can see there's a change to the map. And what's the story you see? Or what information now jumps out at you? We can look at the legend here in the table of contents, which is the same as my symbol properties. And notice that it's breaking our data into these groups. So cities with a population max from 548 to 469,000 are all grouped and using this symbol, which is light yellow. And for the highest rank, has a dark red or reddish brown. Under the color ramp, you can click this drop-down arrow and notice there's all sorts of different color ramps. Right? These are gradations of color and hue. So you can choose one to your liking, but notice the effect it has on the map. So when we're using these graduated colors, is there anything that jumps out at you? Or doesn't jump out at you?
Limited number of colors.
There's a limited number of colors. Yep, we're just using 5. But what's the result in the map?
That scale with that color ramp, there's not a large change.
Yeah, most cities look like they're falling into that first category. Yep. So let's try this graduated symbols option. So here on the left, click on graduated symbols. This is going to change the size of the symbol relative to our value, which is population max. So I'll just click apply. And now what do you see? Immediately it jumps out at you. Look at the Eastern Seaboard. Where are all these large cities? You can see Miami, Houston, Dallas, San Diego, Los Angeles, so on and so forth. So immediately we already have, in my opinion, a better method of representing this message, population of cities in the United States. And we can customize those things. Here on the right, center where it says template, that right center says template, that's going to open that symbol selector again. So if we want to change the color, maybe I'll make mine, I don't know, orange. And then click apply. We can change that template symbol. We could make our symbol size range different. The default is from 4 points to 18. Maybe I want to make my large cities 30 points. I can type a 30 in that box rather than 18 and click apply. So now the big cities stand out even more. So another thing to point out though is it by default grouped things together. So this is the classification. Here at the top where it says classification, the default way it does this is using the natural breaks or Jenks method, which is a mathematical formula that finds differences between things and optimizes those while keeping things that are similar to one another in the same class. Finding the natural breaks in your data. There are different methods we can use to classify. So let's click that classify button. What this is going to do is bring up a histogram of your data, right? So a value of how often different values occur. And these blue lines are where the breaks are in your data. And so you can see in this histogram, this light gray bar here at the very left shows us right away that most of our cities don't have very many people in them. And there are a group with some here with a few more people, and then there are these very large gaps in the data. But our natural breaks method emphasizes these natural distributions. If we click our method dropdown, we have a variety of different options. So the equal interval will look at the minimum and maximum in your data and the number of classes you give it. The default is 5. Maybe I'll bump it up to 10 to illustrate, and it will break your data up into an equal number of classes that you set using whatever division it needs. Another method is the defined interval, where you tell it where to make those breaks. So maybe I want my interval size to be 100,000. Let's see what that does to our data. That gives me 191 classes. Maybe I'll add a 0. Right, still gives me 20 classes. That's quite a few, but you define the interval. A quantile method, let's say if I break these down into 4 quantiles, this breaks up your data and groups the same number of values into each classification. If you're familiar with statistics, a 4-bin quantile is the same as these quartiles. So the lowest 25% of values, middle, upper, and highest. So there are the same number of cities in each one of these 4 classes. There's that natural breaks method, the Jenks. There's a geometric interval, which is similar to our defined interval, but a geometric factor is applied. So if there's some sort of log relationship, or we could also break them up based on the standard deviation of our data. So there's a number of different ways to do this. Notice here in the break values on the right, if I go back to natural breaks, Jenks method, with 5 classes, which was our default, if I type a value, I can click on any of these break values and type a number in, and it will switch to manual. Right? You can also manually classify the data. So I'll just click OK and apply, and then click OK again. Any questions on what we just did? So we're now linking our attributes to the size of these symbols, and we've mapped the population of cities. If you were to give this map to somebody and just say, this is population, most people right away would understand what they were looking at. Oh, the bigger circles mean bigger cities. This is pretty intuitive. What we'll do next, though, is I'm going to turn off this layer, the major cities layer, in my table of contents. I'll also turn off my rivers. And I'm going to right-click on my US state 500K layer and open those properties. So I right-click on my US state 500K, click on Properties near the bottom, and go to my Symbology tab. So here I have these same options come up. I can group things by category. Say if I wanted to make a map out of the name, it doesn't make a ton of sense, but just to demonstrate, if I select the name field here, what I need to do is click where it says Add All Values. And that will scan through that attribute column and find every unique instance of a name, and it's going to assign a different color to it based on this color ramp. So if I click Apply, I'll get a very interesting pastel map where each one of these colors means a different name, a thematic description. But our states data also have a quantitative component. They have a population field as well. So let's go to our quantities. And notice we have a couple more options here, but we have our graduated colors option first. In our value field, let's scroll down and grab that POP 2013 field. And then just grab any color ramp you like to start with and then click Apply. And I'm going to do this one to demonstrate. So in my map, I've applied this color ramp that goes from light blue to dark blue. And now I'm telling you, this is a map of population in the United States. Which states have the highest population? And pretend you can't see the legend for a minute. Just tell me, based on this map, just looking at it. California?
Texas and Florida.
Texas, Florida, how do you know?
Darker.
They're darker, yeah. This is a really common way of visualizing quantitative data across some range. It's called a Chloroplast Map. It uses gradation across a single hue to represent that change. And it's something that is very easy to interpret and it's intuitive. Darker colors in our brains are associated with higher values. So again, this is something you could print off, give to somebody without any other information. So this is population, and they would infer that, say, California, Texas, Florida, and New York all had higher populations. If I were to choose a different color ramp, let's say, I don't know, I'll grab a random one. If I gave you this and said that these represent population, what's the highest and lowest? You could probably use stuff you already know about where there are big cities in the United States and guess, but you don't want to make people guess about the message you're trying to convey. You just want them to look at something and immediately know. So this would not be a color ramp you would want to use to show something that varies across some range. Right, so any of these single color ramps are useful when you're making a chloroplast. And so I like blue. I'll select one of those. And notice what mine did. It's now using the lightest shade of blue and using that for the highest population. If that happens to you, you can right click where it says symbol in the layer properties. And there's an option to flip the symbols. And you can do that at any time for any data set. All right. Notice there's also this field to normal. Oh, sure. Yep.
I don't see the population data. If I go to the cities, or the states, right? Here, the value, like, in water.
You guys don't want to see a lot of that, we were using some grid, right, our grid, we were showing the phenomenon is the graduate colors. Not show.
Yeah.
That's cool.
Yeah.
Okay. So another option we have under the value is this normalization. So we can normalize our data. If we divide one field by another, we can normalize, right? So if I, for my normalization field, choose shape area, for instance, this will read in that attribute, which is the area. In this case, it's in square meters. So I'll get some funky units. But if I click apply, I now see that this is a map of density of people. In this case, people per meter squared in each one of these states. So I see New Jersey and New Englanders will hate me because I don't know which one's This is terrible. I should know this, but much higher population density in these particular states, Maryland and Delaware, than we have for most of the United States. So we can normalize, which is we're dividing our value field by our normalization field. Another option we have to us in the polygon symbology is clicking on graduated symbols. So let's click graduated symbols, click on our value field, and select POP 2013 again. And then click apply. And then take a look at the map. So what did that one do for us? How is it showing the population data with this graduated symbols?
Sorry, the symbols into the polygon.
Yep, so it's drawing each polygon, and then at the center of each one, it's putting a symbol, in this case a circle, and then varying the size of that based on that value. So just like we had for the points. And notice here in our template field, if I click on that, it will bring me to the symbol selector for a point. So I could change the color if I wanted to. And I can also change the background, and that will change the properties for that polygon. Another option available to us is this dot density. So I'll just click on that. And then I'll click on my POP 2013 in this box on the left. And I need to click this arrow to move it over to the right. So again, I clicked on dot density, clicked on POP 2013, and then hit this arrow to move it to the list. And then I'll click apply. And so what this has done, I need to turn off my base map to make it more visible, is that it assigns points randomly within each polygon and varies the number of points based on the value of that field. So you can see those upper Midwestern and Western states like Montana, Idaho, Wyoming have very low density of points, which is just another way of symbolizing our data. And I will choose a different color ramp here, so I get a bolder color. And notice my legend tells me that one dot equals 80,000 people. So this is a way of representing data, quantitative data thematically, that has a different effect. This one is still fairly intuitive, I think.
Did you say those dots are randomly distributed?
Yes. Yep. And if you notice, as you click and change things, the placement will change as you make those changes. There are other options to add things like charts. You can map multiple attributes together. In the interest of time, we won't go into those today. So what I'm going to do is just go back to my graduated colors and set up that chloroplast once again. So I'll click graduated colors, went to my value dropdown, selected pop 2013 with a color ramp, and I need to flip my symbols. So I right-clicked on the symbol, the word symbol, click flip symbols, and then click apply. So going back to these classifications, notice here the break values. In the professional world, if you want to turn in a map where your break values in my legend are 12,886,400, whatever, no, we wouldn't want to do that. For those of you who are grouping data to communicate a message, somebody's going to really want why you chose those breaks. Happens all the time. So choosing the right symbology is just as important as choosing the right classification method. So the Jenks method is nice. It is the default, but you do want to think about which one to use and why. Because just like statistics, you can hide things you'd rather not have people see in a map or emphasize things based on the choices you make. So I've set up in this example, I'll still use that Jenks method, 5 classes, click OK. The final point I'll make is that the number of classes affects the map just as much. So if I go down to 4 classes and then click apply, and I have to keep flipping my symbols every time, there's not a drastic change in the map. But now those 4 states in the highest class jump out at me even more. And I can see the eastern United States seems to have a similar grouping in terms of their population. If I go up to, let's say, 12 classes, now it gets harder to distinguish things, right? So you can add up to 32 classes in Arcmap. But I would have to ask you, do you really want to? Now we have almost as many classes as there are states. So I can look at Wyoming and I see it as less than Iowa, but is Iowa and Kansas and Nebraska here, are they all in the same class? Are they different? How can I relate them to one another based on their color? It's very hard to do. So there's a number of different thoughts on this in terms of classes. I would recommend no more than 5 for most purposes. Some people say 9. It kind of depends on the data and the purpose. Fewer is generally better. But you can adjust the number of classes to emphasize the data you're trying to communicate. I have a question from Jim here. Can we change state size on the map by population? In this case, no, because the state geography represents their actual borders. There are probably ways to do what you're asking about doing, but they're not as straightforward, at least in Arcmap. That's more of a graphic communication or graphical program type of operation. All right. Any other questions? How do you feel about Arcmap so far? Do you like the map you made? Okay. We've made a map of population. There's a couple more tools I want to point out before we move on. One of these is the identify tool. So let's say I want to click on one of these things in my map and learn more about it. I can click this blue circle with a white letter I in the middle, the identify tool. If I click that and then click on a state, it's going to pop up a window that shows me a preview of those attributes. So it shows me identify from the topmost layer. I've clicked on Montana. Here's all the information associated with that. The same tool is available in Art Catalog. You can click and quickly learn more about some feature. Something that's also useful is the Find tool, which I'll close my Identify tool window and then click these binoculars along the top. That Find tool. That may take a few seconds to open, but what we're looking for, we want to find something. Let's say we are looking for a particular state. We can't remember which one is which. Just a minute ago, I couldn't remember Connecticut. So I'm going to find Connecticut. I'll type that within my Find box, and in the In dropdown, I'll select US state 500K. I want to search just in that layer. And so I'll search in all fields, the default, and then just click on Find. And so there, it found some result. And now if I click that result here in my list, it's going to flash these crosshairs and say, okay, that one was Connecticut. And I can manually zoom in. I can also right click here in my results, and I can flash, or I can zoom to that entity, or I can pan to that identity. I can also create a bookmark directly from the results. If I wanted to come back later to Connecticut, I could do that. So if I go to my bookmarks, it shows up in the list. So I can go from Connecticut to South Carolina and back. So this is a really useful tool if you're looking for a particular feature, but you can't remember where it is. The last thing we'll do in this exercise is we'll label some features. Right? So labels are always nice to give context. Any guesses where you want to go to label something?
Delaware.
Or I'll say, how do we add labels to the map? That's what I was asking you.
I'm from Delaware.
Okay. I was going to say the Wayne's World thing. You're like, we're in Delaware.
We're in Delaware.
Right. So if I want to add labels to the map, one of you will notice whenever I ask how to do something, the answer is almost always right click somewhere. So let's right click on our state layer, US state 500K in the table of contents. And there's an option to label those features. So again, I right click on my US state 500K layer, click on label features. And the software is smart enough to know that if there's a name or a field whose title is something like name or ID, it will automatically grab that and use it. If it guesses incorrectly, you can change it from the layer properties. So if I right click on my US state 500K and open the properties, there's a labels tab. And here I can check and uncheck this box to label features to turn them on and off. And here in the middle where it says label field, it grabbed the one name. If it guesses wrong, you can go and change it here. So I could give it the object ID just to show you. Change it back to name. And if I want to change, say, the font or the size or make things bold, I can do those here. So let's label the names of our states and then click OK to apply those changes. Everybody there? All right, let's save our map, but let's save a new one. Let's go to File and Save As. And I'm going to save this as map_2 with my initials. All right. So the last thing we'll do is we're going to start with a new set of data. We're going to symbolize them and then create our first map. So we'll export it either as a PDF or a JPEG. And we're going to symbolize our data and then set up a layout or add elements to a map, such as a title or a legend or a scale bar that you would want to see in a map that goes into a report.
Answer your question about labels before you vote.
Sure.
If you apply labels like this, are you able to, after you apply them, manually move individual labels?
Yes, they no longer are labels as such. You convert these labels to what are called annotation, which is another, it will save as another data set in the geodatabase. They will be their own text entities. And you can move these annotations around, you can customize their spelling, you can delete them, you can make them larger, smaller, customize them in any way, but they're no longer linked to an attribute of a data set. They're their own.
Yeah, so they're just kind of text boxes at that point.
Yes. Yeah, and an easy way to do that, to
There's
start.
no way to manually move them and have them linked.
Good question. I haven't used annotation lately, so I'd have to go and check. You may be able to go back and link them, but generally speaking, if you right click and where is it? There's this option, convert labels to annotation. I won't do it now, but that will create those annotation layers for you based on whatever labels are currently in the map. But I think generally speaking, they are then text boxes and more difficult to link back to the data. Right. Okay, so we're going to make a map. For our first map, we're going to use the 50-meter wind potential data set that we have available to us. So what this is a model of wind generating capacity for a turbine at 50 meters height. It's a fairly standard height for these things. And within that data set are these different classes. 6 different classes that rate the wind generating capacity anywhere from poor to outstanding. So we're going to essentially recreate this map and export. So to start, let's go to Arcmap. And let's go to File and Open. And we're going to look in that Introduction to GIS folder in the Handouts section. And notice there are these map documents. These are for you to reference later on. There's examples of each of the maps from each individual exercise. We want to open this one, Intro to GIS Map 3. We'll click Open. So when it opens, tell me what you see in the data frame. What layers do we have? Again, we can click OK in this business analyst message if you get one. But what layers do we have in our data frame?
Base map, South Carolina wind potential and counties.
Yep. So we have counties, we have our wind potential, and the base map. So once this catches up here, I'm going to turn off my counties because they're covering up my wind potential. I just want to see the wind potential data. So I'll turn off my counties. Okay, so there are polygons. I can see there's a very big one covering most of the state. So what we're going to do is we'll set up the symbology for this wind data, and then we're going to add the counties back on just to give some context to the map. So we're really interested in mapping the wind potential, but the counties will add some more information. So what we want to do is let's set up the symbology for our wind power class. So who wants to come up and show us how to do it? I need a volunteer from the audience. We're going to set these up, in this case, as categories. So I'll tell you that much. Somebody come use that information, show us how to do it. I'll pick somebody. Is it Someone's going to get ready. So Storm, show us where we need to go. If we're going to change the symbology for our wind, South Carolina wind potential here. Oh, sorry.
All right.
Keyboard.
Wrong one.
So, yeah, working in this screen. Cool. So tell us what you're doing as you go.
All right. So you're going to go over to your table of contents.
Yep.
You're going to click, go to
Right-click on our
properties.
layer in the table of contents and go to the property.
Symbology.
Yep, and then we'll click on the symbology tab.
And then you have your fields on the side. This one's a category. So you go to
We'll do categories. Everybody there? Sorry, refresh. It's hard to tell sometimes. I'll give it 30 more seconds, and then if not, you can Control Alt Delete from the task manager. Close it. Yeah. From here, from the Windows Explorer, you can just double click on that map for you. All right. So back to the symbology. Our value field, let's look in the drop down.
So we have ID, WPC, shape area length. I would assume.
Yeah, so WPC is that wind power class. So we're going to select that WPC. And then what do we need to do?
Gotta add your values.
Add all the values. For a category, we need to add those values. So our wind power classes are values from 1 to 6. All right. Thank you, Storm.
Mm-hmm.
Appreciate it. So if you keep coming to these workshops, your turn will come. I will choose all of you. And it only gets more difficult from here. So, just kidding. So we got this wind power class. Let's choose a color ramp. I know we're doing categories, but I'm going to choose one. Whoops, not that one. A gradational color ramp. I'm going to use red as a more intense color and go down to blue. If I can find that one. Where is it? It's at the bottom. Yeah, thank you. Yeah, so we're looking for this one that goes from red on the right to through yellow to blue on the left. And I'll just click apply. So right away I see, looks like offshore is most of our wind potential, but a few locations here. Anybody know what these are? Lake Murray and from South Carolina, so I'm not good at this, but some of these large inland lakes. And then there is this small band up here in upstate in the hills where we have some additional wind generating capacity. And now notice that my table of contents, the legend in my table of contents has updated with this information. So what we're going to do is notice that we have our value field here in the properties that goes from 1 to 6. And then there's this label column. So we can change the label for each of these colors here. So if I click where it says 1, I can type in that box. And what I'm going to do is type the word poor. And I need to open my notes because I can't remember the other categories off the top of my head. We're going to rename 2 as marginal. We'll click on 3 and change it to fair. 4 is good. 5, excellent. And 6 is outstanding. And then I'll click apply, and I notice in my table of contents, it updates right away and changes to match what I've typed. And I'm going to uncheck this box where it says all other values. Notice this count field tells me how many polygons there are in each of these categories. I don't have any other values. So I'm going to uncheck that box. When I make a legend later on, it will leave in an all other values column if you have it selected. So I'll remove that. Click apply. And then there's this WPC. That's the name of that field. But if I want to give this to somebody and have them understand right away what I'm talking about, I'm going to change this label as well. So WPC, I'm going to type out the words wind power class. And then click apply. So now I've got a nice looking symbology. The last thing I want to do is I'm going to change this blue to a white. So I'm going to try and accentuate areas that have some actual wind power generating capacity by taking away this large chunk of the state that is blue. So I'm going to double click next to the letter 1 on that blue box, which opens that symbol selector again. I can go back and customize any of these symbols at any time. And for my fill color, I'll make it white here in the upper left corner. I'll click OK, click apply, and I can see the result in the map. And I will click OK. Is everybody there? All right. So now if I turn on my counties, my goal is I want to use these polygons to give context to see where these counties are, where the wind power generating capacity is relative to the counties, but they're currently covering those data up. I also want to add labels for each county, so I know which one is which. So if I want to add labels, how do I do that? Where am I going to go? Right-click that layer counties _ SC, and I can click on label features, and let's see how smart Arcmap is. Pretty good. It's figured out that there's a name field for each county. Do you notice anything about the labels, though? Especially if you go along the coast.
There are islands.
Yep, so Beaufort County has a variety of different islands that are represented by individual polygons. And it's right now labeling all of those polygons. That looks a little messy. We can change that pretty easily. So I'll right-click my county's SC layer to open the properties and go to the Label tab. And here at the bottom left under Other Options, it says Placement Properties. And if we click on Placement Properties, at the bottom of that window, we can select the option to remove duplicate labels. Or we could place one label per feature, which is what the default was. But we want to remove duplicate labels. Click OK, click Apply. And I see Beaufort just has one label now. Looks much nicer. From my layer properties, I'll go to the Symbology tab. And I'm going to change the symbol for all these counties the same way. So I'll leave my option as this features single symbol. Double click on that box to open the symbol selector. And for my fill color, I'm going to select no color. Or I could alternatively select hollow here as a default. I'll click OK, click apply, and then take a look at the map. Is everybody there? What do you think? Looks pretty good? It's nice, it's clean. I have a good amount of contextual information, but I'll close my layer properties. I can see right away Berkeley County and Clarendon, obviously. They have some additional capacity here. So let's take this map now and we're going to export it. So far we've been working entirely in the data view. And if you look in the lower left-hand corner of Arcmap, there's this tiny little box that's selected data view. And in the data view, we're working in coordinate space, right? So our coordinates in the lower right corner, we're in meters. These are a real world coordinate system. If I click the button next door, this tiny little button that says layout view, this is going to open the layout page where we're now working in page document. So our page size here is 8.5 by 11. So a letter size sheet of paper. And this is where we set up the layout of a map as if we were going to print it. So from the layout view, we do things like add titles, add legends, add scale bars, and so on. So we have our page here in the middle, and then we have this small box that is showing the map we've created. So go ahead and click on that small box. And notice these small blue squares that show up. We can click and drag to resize our data frame. This box here in the layout represents our data frame. Remember an hour ago when I said a map can have multiple data frames? That means that you would have multiple data frames in the table of contents, and they are all represented here in the layout. So you can do things like create a footprint or a thumbnail map. Let's say you're looking at a particular study area within South Carolina, but you want to show where it is relative to the state or the nation. You can have multiple data frames that have those individual maps, but put them together on the page. Does that make sense? All right. So one thing we'll do before we go any further is change the orientation of our page. We'll work in an 8.5 sheet of 11, but let's do it landscape. South Carolina is much more broad than it is tall. So we'll click on File at the top and go to the Page and Print Setup. And here, all we need to do is click where it says Orientation Landscape rather than Portrait, and click OK. So again, I went to Page and Print Setup from the File menu, click Landscape, click OK. And hopefully mine is just thinking. It didn't make any change. Oh, I remember. Did it change for anybody? No, because I forgot to tell you. Click this box that says Use Printer Paper Settings. So if I click that, it will now update. So does everybody have a landscape 8.5 by 11 page? All right, so what we want to do is you can click and drag and move this data frame. You can click and drag the corners to change the size. So I'm just going to expand it to fill the page. Something like this. Something that also should have happened that I didn't point out was this layout toolbar opened for you. Does everybody see that? So there's all sorts of different toolbars available in ArcGIS. The layout tools are useful to us. Notice there are these zoom in and zoom out tools on the layout toolbar. If I click one of those, it's going to zoom in and out on the page, not on the map. And if I click this zoom whole page, it will put my map back in the frame. So how many of you have a very small South Carolina in the middle of your data frame? Right. You can use the normal map zoom tools, say the Michael Jackson hand or these tools, or since we set up a bookmark at the beginning, let's go to SC. So we can go right back to that location. All right. So some elements we want to add. We want to create a title for this. We want to add a legend so people can interpret the color scheme. We want to add a scale bar and a north arrow. They're just very common components of any map. And we add these things through this insert menu at the top. So from insert menu here at the top, let's start by adding a title. Where is it? Near the top, insert title. And what title would you like to give it? I'm going to call it South Carolina 50M or 50 meter wind potential. And then I'll click OK. And it will show up in a text box that I can click and drag and relocate. So I'm going to drag it just above my data frame. All right, the next thing we want to do is add a legend. So if I click on Insert Legend, there's a wizard that has several steps in setting up this legend. The first one is going to ask you which layers you want to include. So on the left are all the layers in my data frame, and on the right are those that are going to show up in the legend that's created. So if there are any base map layers, we want to remove those. I don't see any, but we don't necessarily need to tell the viewer which of these things are counties. That pretty much goes without saying. So we'll remove the counties SC by clicking that name and then clicking this left pointing arrow at the bottom center. So I'll click on counties underscore SC, click this left pointing arrow, and it will get removed from that list. So I can click things to add them if I wanted to put it back, and then I click these arrows to remove them. Everybody with me? All right.
What did you do again?
I went to Insert Legend. Yep. So we'll go back to that menu to add all these layout elements. So once we just have South Carolina wind potential, I'll click Next. We can give a title to our legend. The default is Legend. So you can customize that. I'm just going to leave the default for now, but you can customize the font that's used and so on. So I'll click Next. You can set up a box that surrounds your legend. So if you have a very dark background and you want your legend to pop out, you may want to add a box. So from the legend frame, I'll go to my border to this dropdown, and I'll make it 1 point. For the background, I'll click that drop-down arrow and then click where it says white. It looks like it's blank space next to the word, but there's a color there. So I'll click the space next to the word white. And you can also give it a drop shadow. I'll do gray 30%. This adds a slight edge to the outside and just makes it look nicer. So then I'll click Next. And I'm just going to click Next through these other options. They allow you to customize the patches or the symbol used in the legend. It allows you to change the spacing of elements. But just click through till it says Finish, and then click Finish. So now we have our legend. We can click and drag, and I'll move that to the lower left corner. You can click and drag this box to resize it if you'd like, make it smaller, make it bigger, and it will automatically resize the elements within it. And something I want to point out right now is if I change any of these labels in my table of contents, I can rename things here as well. So this layer name is South Carolina Wind Potential. I'll expand my table of contents. If I slowly double click on it, click once and then click again, I can rename this, and I can even remove a name, and then it will no longer show up in the legend. In this case, South Carolina Wind Potential was redundant. That was also the title of the map. So I can remove it. And I can go and also change any of these labels if I desire, and they'll be updated here in the legend. So let's add a north arrow. Let's go to the Insert menu, click North Arrow, and you can see there's all sorts of different styles. I'm a pretty boring plain guy, so I'm going to pick this one, Esri North 6. That's just a triangle pointing upward. You can pick a fancy one or not, or whatever you like. But I'll click OK. And it will show up here in my map layout. I can click and drag, and I'm going to drag and drop it over my legend, so it's a bit easier to see. And the last thing I want to do is add a scale bar. So again, I'll go to my Insert menu, click Scale Bar. And there's all sorts of different styles of these as well. You can pick one you like. I'm going to pick Alternating Scale Bar 1 and click OK. And I'm going to click and drag it so we can see it a little more. Notice the increments of that scale bar. So mine right now is at the smallest denomination, 15 miles. With my largest being 120. We generally like to make these a little more round. You know, you don't want to have some odd increment. So if I change the size of that scale bar by clicking and dragging on it, it will change the range of that scale bar. So I'm going to make it out to 100 miles rather than 120. And I can click and position that wherever I like.
Can you manually set the?
Yep. If you right click on it and open the properties, there's all sorts of fun things you can do to set up both the units that show whether you want miles, kilometers, feet, meters, whatever. You can specify how many increments to use, what representation you want, and so on. So what do you think? How's it look? Doing all right? Cool. So let's export it. Let's say we want to send it to somebody down the hall so we can show them South Carolina wind potential. We need to export this thing. So we'll go to the File menu. And about 2/3 of the way down is the Export Map option. So this will export it to a file. You can save as all sorts of different types. So TIFF, JPEG, PNG if you like an image. If you want to work in Illustrator or something similar, you could export it to an EPS. You can export it to a PDF if you just want a simple page document. So choose one you like, maybe a JPEG or a PNG or a PDF. You can customize the resolution. So if you need a very high resolution map that you're going to print, you may want to put that up to something like 300. There generally isn't a lot of benefit to going higher than 300. If you need a very small file size or it's going to be viewed very small, you can choose lower. But I'll bump this up to 300 dpi. We can change the file name. So I'll call it South_Carolina wind potential _ my initials once again. I'm going to save this. I'll navigate to computer on the left, back in that Introduction to GIS folder on the data drive, on that D drive. So I'll save that here. Takes a few seconds to export. And now if I go here in Windows Explorer, I see that image file created. I can open it. And there it is. So I could put that in a report, embed that in a website, do whatever I need to do. Is everybody able to get that? Questions? You've done it. I know I fried your brains for 3 hours with GIS. All right. So if there are no other questions on that, I'll just recap what we did. Customizing the symbology of features. We went to the layout view to actually set up the page and add those cartographic components and then export it. So where do you go from here? What do you do after today? If you continue to attend these workshops, just note that these are here to give you skills, but this isn't a class. I'm not going to give you homework most of the time. And even then, I don't require it. I just encourage you to do it. So really, the next steps, if you want to keep doing this, the first thing you need to do is be like the bunny here and practice. Actually, get the software on your laptop. Come to our lab here and just start applying these skills, especially if you have a class project that needs it. That's how you're going to remember the stuff. That's how you're going to learn it, is by using it. Our next workshop is on GIS data creation and management. So we'll talk about coordinate systems, which is a really important topic. We'll talk about some best practices for managing data, and we're going to import data such as scanned maps or aerial photos. We're going to digitize or create vector data. So we'll draw lines, add points, fill in attributes. After today, you're all eligible for those consultation sessions. You can contact us via our website to set one of those up. We have lots of other workshops in the series. So just quickly what we'll do, working with tabular data, we dive into the attribute stuff. So we learn how to query our data, we learn how to join data. And depending on how far we get into data creation management, we do things like geocoding, which is turning addresses into a latitude, longitude. So taking a description of a place and making it a point on a map. Field data collection, we'll use Selector, an app you can put on your phone. We'll go out and map things in the field, show you how to set up data to be used in Selector, in Arcmap. Basic and intermediate spatial analysis, we go through the fundamentals of what spatial analysis is. How do we perform these operations that answer some sort of spatial question? And basic spatial analysis focuses on vector data, intermediate on raster. Starting to lose my voice here. We'll get into a session using LiDAR data, three-dimensional point clouds, which is a really cool type of data. How do we bring those into GIS and use them in processing workflow? We'll use Arcgis online to show you how to make maps in this online browser-based version of the software and create things called story maps, which is a template of a website. But it's a very interactive, cool communication tool. We'll have a guest speaker give a session on Tableau, which is a business analytics software, but also has some GIS capabilities. And then our last session is we'll do some demonstrations of how you can map areas using drones to capture pictures and bring them into a GIS, or use a terrestrial laser scanner, which we also have here in the center. How do we use those things to create geospatial data? And if you attend most of these, most or all of them, you'll receive a certificate of attendance from us, which is a sheet with your name on it that says, I was here and studied these topics, which is nice for employers to see on a resume, for instance. We're about out of time, so I'll go quickly through these things. Other resources on our website, you can request a license for Arcgis software to put on your own laptop. We have a portal for finding free GIS data out on the web. Again, there's a contact us form if you'd like to set up a consultation. There's contact information for some of the staff here at the Geospatial Center. There's a post-workshop survey, if you would please fill that out. Offer your feedback on the session so we can continue to improve as a resource for all of you. That's at this address. If you don't mind filling that out before you leave today, that'd be awesome. I'll stick around for a little while after if any of you have questions you'd like answered right away or want to talk about how you can use GIS in research or classes or whatever. Thank you so much for attending. If you haven't already, please fill out the attendance form. I can pull that back up. Great weekend. A nice long weekend for us, at least. I don't know about you guys. So, thanks so much. You did it. Sure, just 1 second. All right, so you were. And yeah, thanks for your remote attendees. Hopefully that was useful for you guys. This is really the first time we're trying this at a full scale remotely. So please offer your feedback. Let me know how it went so we can continue to do this for you. Thanks.